Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring angle-angle similarity. Before we do, let's review a little bit about similar triangles. Now, similar triangles will have the same shape, but not necessarily the same size. For two triangles to be similar, their corresponding sides must be proportional, and their corresponding angles must be congruent. Now, when you're asked to find out if two triangles are similar, one way you can do this is by using something called Angle Angle Criterion. And Angle Angle Criterion says if two pairs of corresponding angles in a pair of triangles are congruent, then the two triangles are similar. To indicate two figures are similar, we use this symbol. Determine, in example 1, it says determine whether the triangles are similar, and if they are, write a similarity statement. So what we want to try to do is use angle-angle criterion to see if the two triangles have two pair of corresponding angles that are congruent. So what I want to do in triangle ABC is determine the measure of angle C. So to do that, we're going to take 180 and subtract the sum of the other two angles, 45 plus 100. So 180 minus 145 would be a measure of 35 degrees. So I know this is 35 degrees. Now, if you compare triangle ABC to the second triangle, you'll notice that we have two pair of congruent angles that are corresponding. So we can conclude that these two triangles are similar by the angle-angle criterion. So since they are similar, we can write a similarity statement. When you write a similarity statement, it does not matter what order you write the angles in your first triangle, but the order is important in the second triangle. So let me show you what I mean. I would say for a similarity statement here that triangle A, B, C is similar to triangle. Now, here's the important thing. I want to know which angle corresponds to angle A. So angle A, notice that it was 45 degrees. So which angle was 45 degrees in the other triangle? Well, it had to be this angle, which is angle D. So I know the letter D must come first. Okay. Now, going back to our original triangle, our next letter is B. So which angle corresponds to angle B? Angle B was 100 degrees. So in my second triangle, it's angle E that's 100 degrees. So this would be triangle DEF. And this is our similarity statement. All right. Example 2. Determine whether the two triangles are similar. If they are, write a similarity statement. Pause the video and try this problem on your own. All right, welcome back. Let's see, hopefully you first calculated the measure of angle C to be 180 minus the sum of the other two angles, which is 26 plus 90, which would be 64 degrees. So 180 minus 26 plus 90 So our angle C was 64 degrees. Now let's see if we have two pair of congruent angles. So we have our right angle here and our right angle here. Those are the same. Then we have 64 degrees here and 64 degrees here. So because we have two pair of congruent angles, we can use angle angle criterion to prove that these two triangles are similar. So if they're similar, we can write a similarity statement. Before we do though, let me fill in that this missing angle has to be 26 degrees. All right, so again, when you write your similarity statement, it does not matter the order of the first triangle. So I'm just going to put it in alphabetical order again, A, B, C. So triangle A, B, C is similar to triangle. Now here's where it is important to get your order correct. In our first triangle, we put angle A first, and angle A was 26 degrees. So which angle would correspond to angle A in the second triangle? Well, hopefully you said O. And then we went with our 90-degree angle, which was angle M, and then angle N. So triangle ABC is similar to triangle OMN. Right. Example 3. Two similar triangles are shown. Which similarity statement is true? Pause the video and try this problem on your own. All right, welcome back. Hopefully you chose letter C. Triangle TUV is similar to triangle PQR. Now, the reason it's important to know if two triangles are similar, because if two triangles are similar, then we can use proportional reasoning to solve for missing side lengths in two triangles. So let's look at an example of that. In example 4, it says determine if the triangles below are similar and explain your reasoning. If they are similar, set up a proportion to find the side length labeled with a question mark. So remember, to determine if they're similar by angle angle criterion, we need to find the measure of all the angles here. So I do not know what angle S is. So let me see. The measure of angle S would be 180 minus the sum of the other two angles, which is 132 plus 15. Okay, so let me calculate that on my calculator. 180 minus the sum of 132 plus 15. And that would be 33 degrees. So let me put that there. And so that means this angle here is 15. Now, what I want you to notice is that we have two pair of congruent angles. So, yes, they are similar. So we're going to write a similarity statement, okay? Now, I'm going to start with my largest angle. So we would say triangle. If I started with the largest one, it would be triangle RST would be similar to, and then I want to see which angles correspond here. Now, the largest angle in our second triangle is angle D, so it would come first. And then the 33 degrees is our next angle, so that would be F. And then our smallest angle was E. So triangle RST is similar to triangle, I forgot to put the little triangle symbol right there, to triangle DFE. Now, because they're similar, and only because they're similar, that means we can use a proportion to find our missing side. So real quick, let me just highlight the sides we do. We know this side is 15, this side is 20. On this triangle, we know this side is 12, and this is the side we're trying to find here, where there's a question mark. So I want to mark corresponding sides. Corresponding sides. So the side across from the smallest angle, 15, I'm going to put 1 slash from it. And then on the second triangle, the side across from the 15 gets 1 slash mark. Those two sides are corresponding. Then I'm going to put the side across from the 33 degrees. I'll put 2 slashes there. And on the second triangle, the side across from 33 degrees is the 12, so I'll put 2 slashes there. So when you make your proportion, make sure you use corresponding sides. So if I start with the big triangle, I would say 15 is to, and then you look, where do you have 1 slash? That's the question mark, so I'll put X because we don't know it, is equal to. Now go back to the big triangle. I have 2 slashes on the 20, so 20 over, and I have 2 slashes on the second triangle with the 12. All right. So now we'll just use cross multiplication to solve this. So 20x is equal to 15 times 12, which is 180, and then divide both sides by 20. So we get 180 divided by 20 would be 9. So our missing side length is 9. Now, they didn't give us units, so we'll just leave it as x equals 9. All right, example 5. In the diagram below, BX is parallel to segment MV. Determine if the triangles are similar and explain your reasoning. Now, the first thing I want to do is I'm going to look at the larger triangle, the triangle on the bottom. I want to find the missing side length in that triangle. So I'm going to find the measure of that triangle by taking 180 and subtracting the sum of the other two angles, which is 37 plus 52. So that's 91. So I know this is 91 degrees. Now, for our smaller triangle, I know this angle is also 91 degrees because those are vertical angles. Now, I can also figure out what the measure of angle B is. The measure of angle B has to be 52 because those are alternate interior angles. And so the measure of angle X would have to be 37 because those are also alternate interior angles. Now, we know they're similar because of Angle Angle Criterion. Okay, and I don't think on example 4, it said to explain our reasoning. So let me go back up here to this statement right here. Triangle RST is similar to triangle DFE. Our reasoning is by the Angle Angle Criterion. That's how we can prove that they are similar. Okay, so in this triangle, or in this figure here, we can explain our reasoning by writing a similarity statement. So on my small triangle, let's start with the largest angle. So I would say triangle A, our next largest angle is B, and our smallest angle was X. So triangle ABX is similar to, now do the same thing on your big triangle. Start with your largest angle. That was angle A. Our next largest angle was V. And then our next largest angle was M. So there's our similar. Now, why are they similar? They are similar by the Angle Angle Criterion, which says if you have two congruent angles, then your triangles are similar. Now, because they're similar, we can set up a proportion to find the missing side. So let me highlight what we know here. We don't know this side. We know this side is 16, this side is 24, this side is 21. So we can make a proportion to find our missing side. So let's first mark our triangles with corresponding sides. So let's start with side AB. Now, look in your similarity statement. Do you see that AB are the first two letters of the similarity statement? That means that side must correspond to side AV because that's the first two letters of our second statement. So that means I'm going to put 1 slash through side AV. That would go here. Okay. Then we're going to go back to side AX, and I'll put 2 slashes here. Now, what does AX correspond to? Well, notice that AX is the first and last letter. So I want it to correspond to my first and last letter, which is AM. So that would be this side, the 24. Now, when you make your proportion, be sure to match up your two sides. So the 1 slash goes together in one fraction, the 2 slashes go together in the other fraction. So I could say X is to 21 as 16 is to 24. Now I can solve this by cross multiplying. This would be 24x equals, and then we'll multiply 21 times 16, which would give us 336, and then divide both sides by 24. So 336 divided by 24 gives us 14, and they did tell us units here, or inches. All right, last example. In example 6, it says, while playing tennis, Matt is 12 meters from the net, which is 0.9 meters high. He needs to hit the ball so that it just clears the net and lands 6 meters beyond the base of the net. At what height should Matt hit the tennis ball? Now, what I want you to notice in this figure that we've been given is that we have two nested triangles. We have the large overall triangle, and then we have a smaller triangle. So when you have nested shapes like this, I highly recommend you separate them. So let me draw the big triangle first. I'm just going to draw a sketch of it here. So let's pretend like this is the big triangle here. Okay, that's not that straight, but you get the idea. Okay, so this is my right angle. We didn't know this height, but we know this bottom height would have to be the sum of this plus this. So 12 plus 6 gives us 18. So I know this is 18, okay? Now I have a smaller triangle that's nested inside this big triangle, which is where the net is. So I'm going to make a smaller triangle here. And this is 0.9, and we know this is 6. And this was our right angle. Okay. Now, let's mark corresponding sides. So X corresponds to the 0.9, and the 18 corresponds to the 6. Now, what I hope you notice is that the large rectangle is 3 times as big as the small. So I can find out the measurement of X by taking 0.9 and multiplying it by 3, because that large rectangle has to be 3 times the height of 0.9. So let's put that in my calculator here. 0.9 times 3, and that gives me a height of 2.7 meters. So what that means is that Matt should hit the ball at a height of 2.7 meters. And that concludes today's lesson, Angle Angle Similarity.